So, I want to pick up then where we left off yesterday. So, we've been talking for quite some time about ways to describe a function. So we've talked about domain and range, talked about positive, negative, zero, talked about increasing, decreasing, and constant. We've talked about extrema, talked about end behavior, and we've been talking lastly about describing that function as a transformation. Of a parent function. So yesterday we reviewed what we meant by transformation. So we talked about translations, where we slide left or right or up and down. We talked about reflections across the x-axis or y-axis. And we talked about dilation. Again, so we talked about they could stretch or shrink, get bigger or smaller in the horizontal direction or vertical direction. So you could stretch this way, or you could stretch that way. Everybody okay with that idea? And we ended, I believe, let me double check real quick. Yeah, okay. This guy. So we ended with the notion of thinking about the general form for a function. So we said that the parent function is the simplest form of that type of function. So for example, we've talked, or you guys had talked in your previous algebra class about linear functions. The simplest form for a linear function is just the equation y equals x. Some of you remember talking about quadratic functions, because you talked about remembering factoring in your previous algebra class. The simplest form for a quadratic function is y equals x squared. And even further, just a couple of you guys remember talking about exponential functions in your previous algebra class. Not many, but some did. There's lots of different types of exponential functions, but for example, y equals 2 to the x could be the parent function for the exponential functions of base 2. Now we'll go into that in far more detail in second semester. If that's all nonsense and gibberish to you, that's okay. The point of the matter is that these parent functions are just like the simplest version of that kind of function. That's the takeaway. So what we said is for a parent function f of x, let's see, let's see. So for a parent function y equals f of x, any member of that family of functions, when we say family of functions, we mean like if we're talking about the parent function y equals x for the linear functions, we're saying that any other linear function can be written as a transformation of that parent function. Or if we're talking about quadratic functions, we're saying every other quadratic function I can write as x squared, but just kind of changed around a little bit. So that general form is y equals a times f of 1 over c times the quantity x minus h plus k. However, in this class, we're not going to be concerned about the c coefficient. You'll have to wait until your trig and pre-calc class to really talk about those in good detail. And I'll make some mention here periodically why we don't have to worry about that. But in this class, we're only going to really be worried about situations where that c is 1, basically, or where there is no 1 over c rattling around in there. Now, these values for a, h, and k tell us about the kind of transformation taking place. So we have this general form, y equals a times f of x minus h plus k. And depending on the values of a, h, and k, we can tell the type of transformations occurring. So if that a coefficient is less than 0, we have a reflection across the x-axis. If the absolute value of a is not equal to 1, then one of two things has happened. Either the absolute value of a is greater than 1, 1, or it's less than 1. If it's greater than 1, we have a vertical stretch. If it's less than 1, we have a vertical shrink. Make sure you made that change there. As I typoed that one, I wrote in purple. So please double check that. If you're just copying things down, I made a mistake, and it's a big one, so make sure that if you were copying those down, for the a's, that you wrote greater than 1 and less than 1, and not greater than 0 and less than 0. Yes? Yes, sir? The third says if the h is not 0, then one of two things can happen. If the h is positive, it's going to go right h units, and if it's negative, it'll go left h units. And the last thing that can happen is if that k is non-zero, one of two things would happen. Either you're going to go, if k is positive, you'll go up k units, and if k is negative, you'll go down k units. I know. It's exciting. Well, we're going to do some examples right now to kind of practice using this. So let's say we have the example. I'm going to ask for you to describe in words the transformation of the parent function f of x. And we're given the function y equals 2 times f of x minus 1. So the first thing that I'm going to want to do is try to rewrite this in the general form. So the general form was this. So if I do that, I'd have y equals 2 times f of x minus 0 plus a negative 1. Is everybody okay with what I did there? I didn't do much. All I was trying to do was to rewrite my original problem so that it looked like the general situation. And the reason I'm doing that is so that it would be easy to pick out my values for A, for H, and for K. What is my value for A? 2. Everybody can see that? What's my value for H? 0. Everybody can see that? And my value for K? Negative 1. Can everybody see that? on how I identified the values for A, H, and K there? Did I have to do any mathematics to do that? No, I just basically read the formula, right? Okay. So what I'm going to do then is I'm going to number I'm going to number 1 through 4. And I'm going to use that set of criteria that we just wrote down to see if any of those transformations occur. So if I go back and I look at number 1, it says if A is less than 0. What is our A in this case? 2. So A is definitely not less than 0. So is anything going to happen in number 1? No. So I'm just going to put like a dash there to show that nothing happens. Now I'm going to look at 2. It says if the absolute value of A is not 1. Well, our A is 2. Is the absolute value of 2 equal to 1? No. So we do have to consider this. Now I have to check, is the absolute value of 2 greater than 1 or less than 1? It is. Absolute value of 2 is 2, which is greater than 1, right? Everybody okay with that? So we would say then there is a vertical stretch. Everybody happy there? Now let's go to 3. 3 says if H is not equal to 0. What's our value for H though? 0. So do I have to do anything for 3? Nope. Okay. And yes, sir. Of course. The last one is 4. Here we care about the value for K. It says if K is not equal to 0. Is our K equal to 0? No. What is it? -1, right? So which of the two situations do I have? Is K greater than 0 or less than 0? Less than 0, so I know we're going to be shifting down. And I can say 1 unit, since the K was, or the absolute value of K is 1. Is everybody okay with what we did there? Let's do another example. So my first job is going to be to try to rewrite this in the general form. Remember that our general form is that. So y equals -3 times. Notice here in the general form I have x minus h, but in my problem I have x plus 5. How can I rewrite x plus 5 as a subtraction problem? It's a little bit sneaky here. I heard somebody whisper it. I wish you would have said it louder so you could have taken credit for that. We can write it as x minus a -5. Remember, subtracting a negative is the same as addition. So that's our workaround there. And then notice I don't have anything at the end where the plus k should be. So what should I write here? Plus 0. Is everybody happy with what we've done there? So let's write down our values for A, H, and K. And then we'll use those to check the criteria to figure out the transformation that occurs. What's my value for A? Negative 3. What's my value for H? It's negative 5. Can we see that? And my value for K is 0. So, in general, what can we say about the H's? The sign on the H is always going to be the opposite of whatever it looks like in the original problem. So if I have x plus 5, H is really negative 5. Or if I had x minus 10, H would be positive 10. Is everybody okay with that? That tends to be the stickiest point here for this sort of thing, and routinely gives students problems all year long where they have trouble remembering this. So I want to point it out right now, right away, and I'll point it out again and again and again. But we need to remember that the sign on your H is always kind of the opposite of whatever it looks like in the original problem. So I'm then going to write my list, 1, 2, 3, 4. And I'm going to use my values for my A, H, and K, and the criteria we listed earlier to decide what kind of transformation occurs. So if I go back and I look at I look at 1, it says if H is less, or I'm sorry, if A is less than 0. What is my A in this case? Negative 3. Is that less than 0? Yes. So I do have this reflection across the x-axis. So I'll write that where number 1 is. For 2, if I read 2, it says, if the absolute value of H is not equal to 1. Well, our A is negative 2. What's the absolute value of negative 2? Positive 2, which is not 1. So we're definitely in this setting. And I know that 2 is greater than 1, so we should have a vertical stretch. Is everybody okay with that part? Of course. Okay. Next, we'll look at number 3. So if I look at 3, it says if H is not equal to 0. What was our H? Negative 5, which is definitely not 0, right? So we need to look at, is H positive or negative? Ours is negative, so we're going to go left 5 units. Everybody okay with that? And then the last one is 4. So if I go back and I read my criteria for 4, it says if K is non-zero. What is our K? 0. So do I have to do anything for 4? Nope. Is everybody okay with that idea? So is it going to be important that you know those 4 criteria and kind of what they do? Or in fact, we're going to see that over and over and over again the entire semester. This idea of a transformation of a parent function is kind of how we're going to introduce all the graphing that we're going to do in this course. And it'll be even more important in the preceding, or in the following year, when you get to your trigonometry course, because the graphing we do there also relies on this concept of a transformation of a parent function. Is everybody okay with that idea? Okay. Now, let's see. Let's do another. I'm going to give one for you guys to do. I probably shouldn't leave it here. So let's say that we have y equals f of x plus 7 minus 10. So take a minute. Try to do this one on your own. We'll come back together in a couple minutes and go through the answer. So, for this example, hopefully you're able to see that the a is 1, the h is -7, and the k is negative 10. Did anybody get tricked by the h's? You gotta watch out for those h's, right? The sign on the h's is tricky. Yes? So the a should be the coefficient here, right? So if there's nothing being in front of it, like if we have an x, we know it's really 1x. The same idea here, that there's 1 times the f of x. Good question. So if it's an addition or subtraction, then there's nothing there. It's a 0. So if there's an h or k missing, those are zeros. The a is being multiplied. So if the a is missing, it's a 1. Because 1 times anything doesn't change it. Just like 0 added or subtracted from anything doesn't change anything. Grace. Okay. So if I were to write this in the general form, I have 1 times f of. Now this is a plus sign. In the general form, it's a subtraction symbol. So I need to make that minus a negative. And then in the general form, this is an addition symbol and not a subtraction. So I'm going to have plus a negative. So at that point, we can see that the h is negative 7 and the k is negative 10. So the k, the sign, stays the same, right? If it's minus 10, the k is negative 10. The h's, the sign switches. If it was plus 7, the h is really minus 7. Does that feel okay there? Okay. Good question. Again, thinking about why things are happening. The why questions are always good questions. Because it's not only do I need you to, be able to do these things, I like you to be able to understand why we do these things. Because if you get to something unfamiliar and you understand the why of it, you're much more capable of doing something productive and potentially getting a right answer still. Yes?
Okay, so for 8, you put it to negative 7, but then when you wrote it down for left 7,
So the left is taking the sign, right? If it's minus 7, 7 negative is in the left direction. So the left part covers the minus. So left 7 is the same as shifting it minus 7 units. So left, you get what I'm saying? Okay. Good question, though. And it's one of those that, like, as soon as we explain it, it's like, oh, of course, that's why you got rid of it. The same thing with the negative and the down, right? Notice on the down, I dropped the negative also, because down is the negative direction, so we don't need the sign. Yeah. Good. All right. So let's say we wanted to graph a transformation of a parent function. So let's say our parent function is described here. with this graph, and I've labeled 5 points on this graph. And let's say that our transformation that we're interested in is actually, let's put the +1 there. Excuse me, sorry about that. What I would do to start is what we did in the previous problem and get an idea of what this transformation should look like. So if I were to list the A, H, and K, what would my value for A be here? Ryan? I'm sorry, Nicholas.
Yes, I'm going to ask.
Sure.
2 and 2 and -8, wasn't it -2 and -8?
Thank you.
And there's also a second one with 1 and -1 on the other side as well.
Yes, thank you. Appreciate that. Boo-booed some negative signs there. Thank you, Nicholas. Apologize for giving you the wrong name there. Which of the Genords are you related to?
Ryan and Ian are my cousins.
Okay.
And my older brother and older sister Matthew and Jake and brother.
Okay. Thank you. You looked enough like the rest of them that I figured there was some kind of familiar relation.
Yeah.
Okay. Thank you. Our value for A in this case. It is -1. Very good. So notice the negative sign out front, and you can always tack the 1 on there. So we have -1. My value for H. -1. Remember, don't get fooled by the H's. And the value for the K is 0. So because the A value is negative, we get a reflection. Since the absolute value of A is 1, though, there's no stretch or shrink. Since the H value is not 0, we do have a translation, and because that H is less than 0, it's going to go left 1 unit. And then the K is 0, so nothing happens there. Everybody okay with that idea so far? Okay. So I'm going to do this drawing my transformation now in at most 4 steps. In this case, I only need to do 2 steps because there's only 2 transformations occurring. And I'm going to perform my transformations in order from 1 to 4. So the first thing I'm going to do is the reflection. So if I reflect across the x-axis, all of the y-coordinates are going to change signs. Everybody agree with that? So if I draw my intermediate graph here, it's going to look like this. Everybody agree with that? So what I did is I applied transformation 1 to get to there. Everybody agree with that? Is there a question? Now I'm going to do transformation 3, which says left 1 unit. So how is negative 2, 8 going to change if I move it left 1 unit? It would be negative 3, 8. Everybody agree with that? So all of those x and y coordinates are going to, or all the x coordinates, excuse me, are going to subtract 1, and the y's are going to stay the same. And again, excuse my lack of scale here. Notice I didn't include any tick marks. Is everybody okay with what I did there?